I want to do another example of chi-square goodness of fit where you have equal proportions, and I want to go through it start to finish without a lot of the additional explanation so you can see how it actually flows. So the question reads, the concessions manager at Mercedes-Benz Stadium wishes to see whether there is any preference in the flavors of popcorn that are sold during sporting events. A random sample of sales is selected and the data are shown below. At alpha, or at the level of significance of 0.01, are the flavors selected with equal frequency? One of the things at the end, or that is typically true in a hypothesis test, is that typically the hypothesis, or most of the time, is stated near the end of the problem. And so at the end of this question, it says, are the flavors selected with equal frequency? Okay, so again, equal always goes in the null hypothesis, and so we could write the flavors are selected with equal frequency. Again, if it implies equal, remember it goes in the null hypothesis. Now, I could also write that same statement in symbols, because I could say the proportion that like plain is equal to the proportion that like barbecue, which is equal to the proportion that like butter, which is equal to the proportion that likes cheddar. And that proportion is 1 out of 4 because we have 4 different options. The alternative, remember, is the opposite of the null. In this case would mean that they are not selected with equal frequency. So we would say the flavors are not selected with equal frequency. Okay, that one word of adding the word not changes the meaning. Symbol-wise, we could say at least one of our proportions does not equal 1/4 or 25%. Then we need to determine the expected value for each category. I'm going to kind of go back up here to the table that we already have. Remember these pieces that we've been given, this is our observed. This is what really happened. So the row that we're given in this table is our reality. That's what really happened. To calculate the expected, you take the total number in the sample and you multiply it times the probability. Now, we don't really know how many were in the sample. I'm not sure it told us. It just says a random sample of sales. So we can figure out what the total was. We had 25 plus 18 plus 32 plus 45. So my sample size here is 120. So I would have 120 in my sample, a 1 in 4 chance they choose plain, so that would be 30. Barbecue, 120, 1 in 4 chance they choose barbecue, that's 30. 120, 1 in 4 chance they choose butter, again that's 30. And then cheddar, 120 total, 1 in 4 chance that they choose cheddar, so that's 30. So my expected is 30. Then we're going to go out to the website and enter this information. Okay, so we have plain, whoops, misspelled plain there, sorry. Plain, barbecue, butter, and cheddar. Okay, so we've entered the category information. Oops, I misspelled cheddar there. Once you've entered those categories, we click on next, and we need to enter. Oops, it's going slow. Okay, then you're going to enter the number sold or the observed for each category, and then the expected. Okay, so my observed, I had 25 plain, I expected 30. I had 18 barbecue, 30 expected, 32 butter, 30 expected, 45 cheddar, 30 expected. So you enter all of the values, the observed and the expected. We were asked to use in the problem alpha equals 0.01. So we're going to check the little button next to 0.01, and then we're going to tell it to calculate. And it's going to think for a minute and then give us our answer. Okay, so it tells us the chi-square value is 13.267 and the p-value is 0.00409. So I'm going to write that down. Okay, so my chi-test statistic, okay, chi-square goodness of fit test statistic was 13. Getting a little bit of messy writing there. Okay, let me try again. Equals 13. Where is it? It's 13.267, and the p-value is 0.00409. I'm not sure why my pen's acting up. Okay, then you compare the p to the alpha. Okay, so we're going to compare. Oh, goodness. My pen is going nuts on me today. Okay, so then I compare 0.00409 to 0.01. That is less than, so P is less than alpha. Since P is less than alpha, we are going to reject the null. Okay, since we're rejecting the null, then we're going to say at the 0.01 level of significance. And let's see how we worded it. Again, if we've rejected the null, what we're saying is that the flavors are selected with equal frequency is wrong or incorrect. So we're saying that the flavors are not selected with equal frequency. So at the 0.01 level of significance, the flavors, I don't know what's going on with this pen, of, let me type it here because this thing is going haywire for some reason. Okay, let me type it where you guys can see it. So we would have at the, oh, good grief, at the 0.01 level of significance, there is a preference Preference in the popcorn flavors. Okay, and that's enough to say. I mean, that gets us our conclusion. Okay, is at that particular level there is at 0.01 level of significance there is a preference in the popcorn flavors. A little messy, but hopefully you get the gist.